So question number 9, the figure B and CD are given diameters of a circle perpendicular to each other, right? This is perpendicular to each other, and so these angles are all 90 degrees here. So AB and CD are diameter, so it's passing through the center. The length of this is given 7. So obviously the radius is 7. So OA, OB, OC, OD all are 7 each. Now the question is find the shaded region. So shaded region is this circle and also the two portions that you find in the semicircle besides the triangle, right? So this is the shaded portion. So in the shaded portion, what you will do is area of semicircle can be easily found out by using half pi r square. The radius of the semicircle will be 7. So half pi r square minus, this is a right angle triangle, because we know that angle in a semicircle is 90 degrees. So this is diameter, so angle C is 90. So angle in a semicircle is right angle. So I can use the formula half base into height, half of 14 into 7. So 7 and 7, 14 is the total diameter, height is 7. This is perpendicular, so this is the base and this is the height. So half pi r square minus the triangle half base into height plus this circle is having a diameter of 7, so radius will be 7 upon 2. So what will be the shaded region? The shaded region will be area of this circle as it is. So that is why we have applied this formula 22 by 7 into 7 by 2 into 7 by 2. So this is pi r square for the circle here. So pi r square radius of this circle is going to be 7 upon 2. So that is why we've got this pi r square plus, what is this? Half pi r square. Now we are taking the semicircle minus the triangular portion. So here the semicircle minus the triangle is going to give you these shaded portions here. So semicircle is half pi r square. So from half pi r square, you will subtract half base into height, that is this triangular portion, and you will get the shaded portion. So this circle is as it is, that is pi r square. Then for the other shaded region, we are using half pi r square minus half base into height. So when we solve this, you can easily cancel off the 7s. Then this is 11. So 11 into 7, 77 by 2. We get this 38.5. And then the next part, we are solving this pi r square minus half base into height. So this is getting cancelled here. And this is pi r square. We cancel this. Okay. So the total area of the shaded region we will get as 49. 66.5. So that is 28 plus 38.5. So here we get 28, right? So here we calculate this 7 is getting cancelled. This is 11. So 77 minus 49, that is 28. So 28 and 38.5 we get 66.5. So total shaded region will get 66.5. Then we go on to the next sum, question number 10. Now, question number 10 is an equilateral triangle. Okay, this is an equilateral triangle. All the sides are equal. The area of the equilateral triangle is already given to us, 17320.5. This is already given to us, 17320.5. Now, area of an equilateral triangle formula is root 3 side square by 4. So root 3 a square by 4 is 17320.5, and the value of root 3 is, remember, given here 1.73205. So when I calculate this, this becomes very easy because a square will be 17320.5 into 4 divided by 1.73205. So when you calculate this, you have to remove how many decimals here? 1 decimal removed, 1 decimal removed, then 1, 2, 3, 4. So I have to remove 4 more decimals. So I am going to multiply this by 10,000. So 1732005 will get cancelled. 4 into 10,000. That's why we get a square as 40,000. So a square is 40,000. So a will be root of 40,000, and root of 40,000 will give us 200. Now once you get this total length as 200, the radius is going to be half of that because this is made up of 2r. So twice the radius is 200. So radius therefore will be 200 upon 2, that is 100. So radius aa gaya 100 and the theta is 60. Why? Because this is given that it's an equilateral triangle. If it's an equilateral triangle, theta is 60. So what will be the shaded region? Shaded region is in between here. It will be area of the triangle which is already given minus area of the three sectors. So sector formula will be 3 times pi r square theta by 360. So 3 times pi r square theta by 360. Radius we have already found given 100 and theta is 60 because it's an equilateral triangle. Pi value they have asked us to use 3.14. So the final answer of three sectors is 15,700. So the required shaded area will be area of the triangle, which is already given to us 17320.5 minus area of the three sectors. So we will get the area 1620.5. Okay, so shaded area will be 1620.5. Moving on to the next question. We have question number 11. There is a square handkerchief and on there are 9 circular designs made. We have to find out what is the remaining area. Okay, so 9 circles we have to subtract from the square. So radius is given 7. If the radius is 7, that means each circle will have a diameter of 14. So 14, 14, 14. So total side of the square will be 14 into 3, that is 42. Okay, so side of the square will be 3 into 14, 42. Now we know that remaining area will be area of the square minus 9 circles. So that is side square minus 9 pi r square. So 9 into 22 by 7 into radius is 7. So when I calculate this, I get area of the square 1764 minus 9 circles 1386. So required shaded part or the required area remaining portion will be 378 centimeter square. Question number 12. We have question number 12 with us here. This is OACB is a quadrant. Quadrant is 1/4 of a circle. Radius is given 3.5. OD is given 2. So this distance is 2.0 centimeter. This distance of the radius is given 3.5 centimeter. Question is find out the quadrant. Quadrant is 1/4 of a circle, or we can use pi r square theta by 360. It's same thing because when you cut this you get 4. So 1/4 pi r square. Radius is going to be 3.5. So 3.5 can be written as 35 by 10, and that's why we can reduce it to 7/2. So you can either take it as 3.5 or we can write it as 7/2. There is no problem. So required area will be 1/4 pi r square, and you get the area of the quadrant as 77/8. So here they are using pi r square theta by 360. You could have also used 1/4 pi r square. Now shaded region, that means this area that is shaded here can be found by subtracting the triangle from the quadrant. And triangle's area, this is a right angle triangle here, so we can use half base into height. So half into 7/2 into height is 2. So we can easily calculate this and get the answer as 49/8. So required area in this will be 49/8. Question number 13, you can mark this question important. Question number 13, there is one important thing here, that the length or the side of the square is given 20. So we know that all sides are equal in a square. So we need to find out the radius. Now radius was unknown. This is the radius is unknown. So please remember there is also the diagonal of the square. So diagonal of the square is also the radius. For the square it is diagonal, but for this quadrant it is the radius. So diagonal, there is a formula √2 into side. You can also use Pythagoras to find out this, it's okay. But you can use this direct formula that diagonal of a square is √2 into side. So radius will also be √2 into side. So that is why we can say radius is 20√2. Okay, so the construction is join OB, and we can find out the radius by joining OB. That will be diagonal of the square, which is √2 side. So √2 into 20, 20 √2. Now once you do that, it is very simple. The shaded area need to be found out, that is area of the quadrant minus area of the square. Now area of a quadrant again, I'm using pi r square theta by 360. I can use 1 by 4 pi r square minus area of the square. Area of the square is 20 square. So when I calculate this, I can easily find this by substituting the value of pi as 3.14 as given. So 628 minus 400, we get the answer as 228. So 228 centimeter square will be the shaded area of this question. Question number 14, again simple question. Find the shaded area. These are two sectors. These are two sectors. One is a bigger sector, one is a smaller sector, and we want to find out this area, shaded area here, right? So the shaded area will be the bigger sector minus smaller sector. So what is the bigger sector? Pi capital R square theta by 360 minus the smaller sector pi r square theta by 360. So what is important to understand here is that only the radius is changing. So we can take pi theta by 360 common. So pi theta by 360 is common, and inside the bracket we get r square minus r square. So pi theta is given 30. So pi theta by 360 is outside, and inside the bracket we get capital R square minus small r square. And what is capital R? Capital R is already given 21, and small r is given 7. So when you substitute that, we get 441 minus 49. So this we can cancel 12 times. Again, we can cancel this 6 and 22, we can cancel 11. So 1 by 6 into 11 by 7 into 392, I can solve this. So when I solve this, I'm going to simplify it and get it the answer as 308 by 3. So that will be the shaded region. So we can cancel this 7 and 392, 7, 5s are 35 and 6. And this will become 28 by 3. So that's why we get 308 by 3. Then question number 15, important question. This is a triangle. This is a semicircle. And here you find that this white portion is a quadrant. So how to find out the shaded portion? The shaded portion is this portion here shaded can be found by adding the triangle plus the semicircle, subtract the quadrant. Okay, when I add the triangle and semicircle, I'll get the full area. From the full area, I'm going to subtract the quadrant. So area of the triangle is half base into height because this is a right angle triangle. The sides of the triangle can be taken as 14 because the radius is 14. And diagonal is, I told you in the previous sum, diagonal is root 2 into side. So this diagonal is 14 root 2. So when the diagonal is 14 root 2, what will happen? This is also the diameter of the semicircle. So radius of this will be 7 root 2 if you are considering the semicircle. Of course, for this quadrant, the radius will remain 14. So the total area, if I want to find out the shaded portion, first I'm going to use the area of this part, that is area of the semicircle and triangle I will add. So semicircle area is pi r square by 2, okay, because full circle is pi r square, so half circle or semicircle will be pi r square by 2 or half pi r square. So pi radius here will be 7 root 2 because this BC length is 14 root 2. If BC length is 14 root 2, the radius of this semicircle will be 7 root 2, so that's why they have put this 7 root 2. So pi r square by 2, pi r square by 2 plus area of the triangle, half base into height, that is half 14 into 14. So you get the area of the full figure minus you are subtracting the sector. This is the white portion or the unshaded portion. The sector is pi r square theta by 360 or 1 by 4 pi r square, and the radius is 14. So when I calculate that, I realize that the first part and the third part are identical, that is getting cancelled, and you are left with area 98. So area of the shaded portion will be 98 centimeter square. The last question, calculate the area of the shaded portion here. So in this shaded portion, actually, if you make a diagonal, then this is a segment and this is another segment, right? What is a segment here? So if I'm drawing like this is a segment, isn't it? For a circle, we know what is a sector and what is a segment. This is a segment. So here, this is actually two segments. Okay, and if I find the area of one segment and multiply by 2, I will get the area. So that is why we've got area of two segments. And what is the formula for area of segment? It is pi r square theta by 360 minus area of the triangle. In this case, it's a right angle triangle, so we can use half base into height. So pi r square theta by 360, that is pi, we are going to use 22 by 7. The radius is 8. Okay, this is 8. Radius is already given to us. Theta is 90, already given. So pi r square theta by 360 minus half base into height. So in a triangle, we know that area is half base into height. So half into 8 into 8. So we get 64 by 2, 32. And when we solve this, you will get area of one segment, and then you have to multiply it by 2. So when you multiply by 2 and solve, the final answer you will get as 256 by 7. This will be our final answer. So the required area can be found by finding area of one segment and multiplying by